Hello friends. Now the most important topic. Several time it was given in G and boards questions. Coulomb's law in vector forms. But before starting Coulomb's law in vector forms, we will try to recall some previous things. For example, you know that the k is a constant. F is equal to k q1 q2 by r square, and k is dependent upon the vector on median. And what is the value of k? In the value of k in free space or space and air, in air slightly different, that is equal to 9 into 10 to the power 9 Newton meter square and Coulomb square. And vacuum is also the same value, and where epsilon naught, this is the permeability of a medium, we will discuss later. Some more things. What is the main points of the Coulomb's law? First, Coulomb's law shows the interaction between two charged particles. Second, it acts along the line joining the center of the charge. Third, force is directly proportional to the product of two charges. And next point, it is universally proportional to the square of the distance between the center of the charged particles. And then when we combine all the things, we get F is equal to k q1 q2 by r square, but this is in a scalar form. One more thing I would like to discuss: force inverse square law. Force inverse square law, this is also follow in gravitational laws. If we plot a graph between force and distance, that is separation, the force and separation graph, we obtain such type of graph. Means when we decrease the force, the separation will be increases, or we increase the separation, the force will be decreases. Okay, now, and there are some questions, simple questions, on very direct question. What happens when we double the distance between two charged particles, and what happens when we halve the distance between two charged particles? You know very well, by using the formula, if we double the distance between two charged particles, the force became 1 by 4 times, and when we half the distance between two charged particles, the force became 4 times. Okay, now we will start the Coulomb's law in vector form. We have two charges, plus q1 and plus q2, and separation between them is r, modulus r. We take it in modulus r, means we have required only the magnitude. So look here, there is q1 and there is q2, and the distance between these two charged particles is modulus r. Okay, this is modulus r. Okay, now when we consider force on first charge due to second charge, then we should write here F12. The value of R is equal to R1 minus R2. We have little knowledge of the vector forms. Let us suppose this is the origin, and there is a first charge q1 and there is second charge q2. You know that if we consider the force from the force on first by second, we should write here F12. F12 means the final point is 1, and initial point is 2. So we should consider modulus r is equal to r1 minus r2, modulus. Okay, now F12 is equal to K Q1 Q2 by R square. This is the scalar form. To convert into vector form, we have required unit vector F12 K Q1 Q2 by R square modulus R square. Then for unit vector R1 R2, and we use here cap. We know that A cap, this is the unit vector of A, is equal to vector A by modulus A. So then similarly R1 R2 cap is equal to R1 minus R2 by modulus R1 minus R2. Okay, now for R1 R2 cap we should use R1 minus R2 by R1 R2. Then we write here K Q1 Q2 by R square, R1 minus R2, R1 minus R2. Next, look here. We know that what is R? R is the modulus, and the modulus of R2 minus R1 or R1 minus R2 both are same. So for this we should write here modulus R. In the place of R we could write R1 minus R2. Then the square of R modulus R square, that is R1 minus R2 square. So right here K Q1 Q2, and this way we will get Q1 Q2 R1 R2 by R1 minus R2 modulus the whole power 3. Similarly, if we have to write the value of F2K, this is equal to K Q1 Q2 R2 minus R1 by modulus R2 minus R1 the whole power 3.